Okay, so the simulation is completed for this lab number 2. Let's go to the results to see what's going on in this model, and we can now check the cumulative deformation in this model, and we can control it now. So let's say make it to 50. If you notice here, we have some loading and unloading status. You can see here we have loading and unloading status, so which represents that how this separation of the surface is occurring here. So if I go to option in common and click on featured edges, I need to just make things simple for myself. So this load is applying here, some worst phenomena is occurring here, and because of that we are getting this response, and this top wearing surface is separating from the bottom layer, which is a good gesture that this model is working fine with, even with this separation as well here. So let's simulate it and let's see what's going on in this model. So you can see here focus on it, right? And let me show you the deformation here as well, the permanent deformation. If I go to field output request here, and for maximum principle, okay, unique nodal, and select this one. So you can see that this deformation is increasing with respect to time of each cycles, and this permanent deformation is occurring in this model, right? So although it is small, but this deformation is occurring in this model. And if I select centroid and click on this model, click on done, click on plot, you can see that with each respective cycle this permanent deformation is occurring in this model, right? So other than that, you can look at the stresses as well, right? So, and also you can look at the other details just in case if you are interested in it. So with each repetitive pattern, the cumulative stresses are increasing in it, although we are not getting a very high deformation, but this model shows here what's going on in this model. So let's go to view and specify about y-axis 0.45 to rotate this model, and go to view part, show legends only, apply OK, go to view and animation, ODB display options, click on general, go to view, graphic options, and make it white, click on apply, click on OK, then try to change it to isosurface, which is not a good way to consider, because, but yeah, I think this is a good way. And go to options, common, and make it free edges here. Now we can kind of show it in this way, and with this deformation, with banded, we can show this deformation in this way. Other than that, we can look at here that if we play with the limits and change it, we can visualize that those stress bulbs are showing here and the stress is moving forward. But I think we should keep it like this, and with minimum and maximum tag here, what's going on here in this model. And after that, let's look at the other colors and style spectrums, blue to red, or reverse rainbow, or white to black. We can check what's going on, wrap around, right? So I think white to black would be fine, and show the bounded surface as well. We can make it more interesting by converting it to black. Click on apply, right, and okay. Now let me just do one thing more here, and go to options and common, and in free edges, instead of free edges, I will select exterior edge, and then I will select this corner. I will say click on OK, and go to where okay, I don't remember right now. There was an option for okay, yeah, Cartesian coordinate system. So let's create a Cartesian coordinate system. Then we have this point and this point. So X, it's Y and Z. So I'm going to go options and common, make it free edge. It's like this, right? And oh, sorry, but yeah, we can do it like this as well. If I go to mirror and sweep, sorry, mirror pattern, and instead of that, the one that I created, I use this coordinate system, and I switch to YZ and click on apply. Now I can see what's going on in this model, right? So after that, I can, when I play this, you will observe how the deformation is propagating in this model, right? So we can control this behavior. You can work on it to make it more interesting, right? And generate some outputs from it, right? So we can also make it more eye-catching. If I go to options, common, and make it non-uniform. So on X 250, click on apply, 500, click on apply. Yeah, so that's okay. Now I think it's a good way to present it. And let's go to animate and save as. Instead of ABI, I will quick time and call it lab 2, and I'll just make it like this. So this is just a temporary animation that I have created here, and moving forward, we are going to discuss more interesting phenomena in this modeling environment. right? This is just to make you familiarize with the process. So let's make it once, stop it and close it. So I'll close this. I'm not interested in it anymore. I will look at here. We have this animation file. Right, so it is a huge file, but since we generated this, so it's working fine for us. So how much we have covered up to, I think the lectures that I have covered up to this point, 9, 10 and 11. So this is covered in lecture 9. To 11, right? So let's make it more simple. So in lecture 9, 10 and 11 we have covered this lab 2, and this is discussed in lecture 9, 10 and 11 as well. So let's copy this, paste it here. This is going to be covered in lecture 12, right? So I'm just making it simple to change this progress, and yeah. So these 3 points that these 3 points that I'm considering here, these are in the next lecture, and then I will switch to this discussion and do some further demonstration as well. Then there is a grain to grain discussion in this course, so I'll try to discuss this as well. If I'm trying to model each and every detail, it will be a best way to consider, but we need to make sure that what are the possibilities. For example, if I consider grain to grain discussion context, then how we can do it, right? So there are various ways to consider these process, and we have to make it more interesting by introducing all the possible methodologies that we are getting here, right? So I think it's not difficult to continue with it, although the course will be lengthy, but we will cover a lot in it. Thank you so much for watching.